In this video, we are going to learn how to apply superposition theorem for an AC circuit. First, let us see the principle of superposition theorem. The theorem states that the voltage or a current in an element is the algebraic sum of the voltages across the element or the current through the element due to each independent source acting on it. So the statement is well aware to you as you have applied this theorem for DC circuits. So let us see the steps how to apply the theorem. First, turn off all the independent sources except one source and find the output. The output means either the voltage or the current. So repeat this step for each of the other independent sources. Then the total voltage or the current in that element will be adding all the individual outputs due to the independent source. So maybe you think that the statement is little bit difficult to understand. Let us see how this to apply on a circuits where you get the clear idea of how to apply the superposition theorem. So this example is for an AC circuit. So let us take this circuit. See, we have two sources. One is a current source and another one is a voltage source. We have to find the current Ix. Before going to apply any analysis technique to an AC circuit, the first thing we should look into is the values of the elements. They should be in ohms, what we called as impedance. So if you look into the inductor and capacitor, they should be converted into ohm values, and the equations of current and voltage should also be changed into polar form. So this conversion we call it as change them into frequency domain. So this change we are doing for analysis purpose. Actually they are as it is, but for analyzing to find the current we have to convert them into ohm values and the sources to be in polar form. So let us see how to convert that. So before looking into that, let us derive what will be the current Ix by superposition principle. This Ix will be equal to I1 plus I2. I1 will be the current due to one source and I2 will be the current due to another source. So here I1 is due to the voltage source active and I2 is the current due to the current source active. So the actual current Ix will be equal to sum of the current I1 and the current I2. So we are going to find these two currents I1 and I2, then the Ix. Before that, our circuit should be in frequency domain. It means the values should be in ohms for the elements and for the sources it should be in polar form. So to convert them into ohm values we need the omega. See, look into the two sources. The two sources has the omega as 2 and 2. So the omega value for the entire circuit is 2. So take the current source, convert this current source into a polar form. The maximum value is 5 and the angle is 10. Next, for the voltage source, the maximum value is 10 and the angle is minus 60 degrees. So whatever the sign comes with your angle, we should take it up. So it is simple to represent it in polar form. Next comes our inductor and capacitor. So to change the inductor into ohm value, the formula is J omega L. Our omega is 2 and inductor value is 4. So J into 2 into 4 gives us J8. Next to the capacitor. To change the capacitor into ohm value, the formula is 1 by J omega C. So 1 by J omega is 2 and the C value is 1 by 8. When we use a calculator to calculate it, the answer will be minus J4 ohms. So we have changed all our values to be in frequency domain. So now we can apply the superposition theorem to our AC circuit. So we are going to take only one source active as per the statement of superposition principle. So let us keep the voltage source to be active and we'll cancel the current source. So how we can cancel the sources? If it is a current source, the current source should be open circuited. So if we open circuit, then the current is 0. So that's how we'll cancel the source. So if we want to cancel the voltage source should be short circuited. So that the voltage value will be 0. So first we are going to take the voltage source to be active. So the voltage source is active. We cancel the current source by open circuiting it. So the current, now that current we named it as I1. So before looking into the calculation, keep it in mind the values are in complex number. So our calculator should be in complex and degree mode to do the calculation. So all of you keep your calculator in complex and degree mode and we'll start doing the calculation now. So looking into the circuit, we need to find this current I1 and we have a voltage source. So the current I1 will be the total current of the circuit if we look that circuit alone. It's a single loop circuit. So what we can do to find this current I1? Yes, apply the Ohm's law. By Ohm's law, the current I1 will be equal to V by total impedance. Yes, here the word is impedance. The voltage by the total impedance. So I1 will be equal to, the voltage is 10 angle minus 60 degree divided by the total impedance 3 plus J8 ohm minus J4. So which will be equal to this much. So we'll keep like this. So the current I1 we found by applying the Ohm's law, V by total impedance. So next, the other source should be active, that is our current source is active and we should cancel the voltage source. Voltage source can be cancelled by short circuiting. See, we short circuited it and the current source is active now. So the current is here. We name this current as I2. So now which technique we can use to find out this current? We have a current source. The current comes here. See, the current gets divided between these two branches. So which technique? Yes, apply the current division rule to find your current I2. So I2 will be equal to the total current 5 angle 10 degree into the opposite impedance. So we are finding the current, we have to take the opposite impedance J8 divided by the sum of these two impedance value, which gives this answer. So we found out I1 by keeping the voltage source active. We got I2 by keeping the current source active. So what is the current Ix? The current Ix will be equal to I1 plus I2. So I1 and our I2. Do you take your calculator, do the calculation, and we'll get the answer as 9.902 angle minus 129.71 degrees. So hope you understood how to solve the problem by superposition theorem. So once again, we'll summarize the points. So before applying any analysis technique for an AC circuit, we should check each element values. It should be in ohms and the sources should be in polar form. So once you have done that, you can apply the techniques. So we kept like that and we applied our superposition theorem and we find out the current Ix. Thank you.